Welcome to UVM. I'm Chris Landry. I'm the chair of the chemistry department. I love introducing people to the new features of our STEM complex, so I'd love to take you on a tour and highlight some of the different information and different aspects of the building that we have. Starting here in Innovation Hall. Innovation opened in May of 2019, and Innovation Hall houses mostly lecture halls, conference rooms, faculty offices, so lots of spaces for interaction and learning. In a little bit, we'll take a tour of Discovery Hall. That opened in May of 2017, and that is mostly labs, so teaching labs, research labs for chemistry, physics, and a few engineering faculty. It's been a real plus for us to be co-located with our friends from other departments and other colleges in one area. That's another real strong feature of the STEM complex is the shared spaces where, again, there's a lot of interaction, not just students, but here it's faculty and chairs and secretaries interacting. So, wide open spaces, nice, bright places to work. That's another hallmark of the STEM complex.
I'm Randall Hedrick. I'm the chair of the physics department. So I'm going to give you a little rundown on the active learning classroom. The classroom is different from a regular lecture hall in the sense that the students, instead of facing the front, they all face each other. And so the lecturer is not the focus of the class activities. Rather, it's usually group discussion, problem solving, and some type of activities that may be a hands-on activity. So the students are focused into groups, and 3 groups per tables and 3 students per group. So they'll be doing, working together, and then they can have also whole table discussions. The instructor can interact with them. One way to interact with them is through the displays. So each table has its own display. And then one cool thing is behind each display is also a whiteboard for discussion, and we have additional whiteboards around the room. Since we've been doing this active learning mode, we've found that the students perform on our force concept inventory evaluation about 20 percentage points higher than the national average for a traditional lecture course. Contrasting with a passive mode, that they are thinking all the time through class, and so they're, I think of it like playing basketball. You don't learn to be a great basketball player by watching basketball. You have to get out there and practice, and so the active learning is really practice.
So this is an organic chemistry teaching lab. This one is used primarily by chemistry majors. What I like to point out is, you see lots of wide open spaces. There's lots of, again, spaces for student interactions. Students can work in pairs at each of these. These are called fume hoods or reaction hoods. And again, they have glass sides and everything, so everyone can see what's going on. It doesn't obstruct any of the sight lines. And so there's, a high volume of those hoods in there actually. It's kind of a nice feature that I think many older university chemistry labs don't have. And it's important in terms of safety, especially for organic chemistry. There's lots of solvents and things that have fumes. So the students can keep everything contained inside the hood. They can pull the sash down. And then, like most of the spaces that are in Discovery Hall and many of the ones that are in Innovation Hall, they're occupancy sensitive, so the lights turn off when you're not in there, but also the airflow drops when there's no one in the room. And that's really important in an area like this that has a high airflow capacity. It can be really energy intensive, so having it be occupant sensitive means that the building saves a lot of energy. It's well designed to make it a safe place to work, but yet still save a lot of money and energy. We're in one of the research areas in Discovery Hall for your Department of Chemistry. This is actually my research area. And so what's different from our old building again is that the chemistry research areas are all contiguous. So one runs into the next, So it's not like everyone was working in their own independent kingdom. If you're a grad student or an undergrad, you see what people are doing in the next research lab. So you learn who's working in there and what they're doing. So that's kind of a nice feature in terms of interaction again. When you can sit down on a piece of paper and design your own research lab, it's a really nice opportunity. So the space is very efficiently used. So all the faculty members in our department had the opportunity to really sit down and design their own area. Another nice feature that you don't always see in this building, and that's how complicated the construction really was. So there's lots of different electronics going on, lots of different gases, and there's house vacuum, a big pump in the basement and stuff. So looking up, I think, really tells you a lot about how complicated the building actually is. So maybe if we can take a look over here, right, you can see that a lot of the equipment is actually not plugged down, it's all plugged up into the top. So that grid supplies ventilation, water, gases, electricity, everything. And that's really key because it's easy to just disconnect something. You can restructure what's underneath and then plug it back in again. So the space is also really flexible. So if a faculty member leaves or a new person comes in, or you change the instruments that you want to use, it's very easy to move things around quickly and get up and running as fast as possible. We're on the second floor of Discovery Hall, so that's another teaching lab floor. The second floor has general chemistry teaching labs. In comparison to the organic labs we just saw on the fourth floor, there's many fewer hoods. So that describes the kind of chemistry that's going on, right? So fewer solvents. But what's different also is that there's more tables. And so this is, again, purposely designed. So in this sort of format, we have students working together in teams of 2 or 4 in general chemistry for life science majors, Chem 31. They'll be working on recitation sections, so they do problem solving before the lab even begins, and they talk about the lab at the end. So again, in our old building, there were many fewer opportunities in a teaching lab for interaction. In fact, students had to stand the entire lab because there was no place for them to sit down. So we try to solve those kinds of problems and really make it very interactive again as well. So the reason for the design is to encourage that kind of student-led discussion. You can also see in both of the labs that we've seen today that many of our teaching labs are run by our graduate students in the department. So that's a great opportunity for them if they're interested in learning how to teach. And then it also means that we can break students down into smaller groups to encourage more close discussion and close interaction. So this is one section, laboratory section. The lecture associated with this would have about 100 or 150 students in it. So it's another way to have a really close interaction with someone and learn some chemical skills and chemical techniques. Right now we're in one of the large lecture halls in Innovation Hall. This is again a newly designed lecture hall. But what's nice about it is it's like super modern. So there's 3 different projectors, there's 3 different projection screens, there's all different kinds of remote controlled lighting, so you can set it up if you're giving a seminar in here, if you're just teaching a normal lecture class, if you want to watch a movie in this room, you know, it's all controllable from the front podium over there. There's another thing I wanted to point out though too, like I remember having a long discussion when we were thinking about designing large lecture halls about how to encourage students to work in small groups of 2 to 4, even in a 100-person class. So it's something as small as where you put the chairs and where the sort of tables are located. So if you notice, each one of these long tables is located on its own platform. So there's 2 per platform. So students who are sitting here can just take these chairs and spin them around. And now you have a group who can work together, and it can be happening on every level. So that's another thing that I've done teaching in this kind of large lecture hall, is take an 80 or 100-person class and then have students just break up into groups of 2 to 4 and then work together on problems for 10 or 15 minutes of the class. And then they can turn their chairs back around, we can start the lecture again and then sort of review what they've done. So that's really nice. And then the final point I would make is the Wi-Fi capabilities in here also mean that if students are working on tablets, they can connect remotely to the computer and we can actually put their individual work on the screen. All of the lecture halls, the large lecture halls in innovation, have demonstration tables at the front. So the reason that there's a sink and all this like electronics and Wi-Fi at the front is so we can do physics and chemistry demonstrations during class. So we finished our tour of Discovery and Innovation Halls in the STEM complex here at the University of Vermont. So I hope you've had a chance to take a look at what the opportunities are in our new complex, to think about coming here. I hope you've been interested enough to take a closer look. And if that's the case, you can always get in touch with me through the chemistry department website at the University of Vermont. And again, my name is Christopher Landry. If you're interested in physics or math or computer science also, you can get in touch with those chairs on the UVM website as well. So with that, I encourage you to take a closer look, and I hope to see you sometime soon on campus. Bye.